Well, hi, and welcome to my shop, and thanks so much for joining me here for day 2 on this Westinghouse 981 multi-band receiver. I think things are going to be quite straightforward with restoring this radio. The last video at the end I had it operating. May not have been performing well. Difficult to say really what the quality of its performance is, or was. Lots of capacitors in here to change, but I think it's going to be quite straightforward, as I said. But there's a couple of interesting anomalies here to take a look at first, I think. One of them was the what I believe is a type of sort of a bench-built capacitor here, or factory-built capacitor here, a twisted pair of wires. Another one is this wire to nowhere. What is this all about? And the last one, a new one. What's this wire doing? This wire's hanging out the back, comes in, and attaches here in a circuit somewhere. It's not going to the chassis or going to ground or anything like that. Why would this be sticking out here? It's off the antenna terminal. Well, it seems to be skipping this capacitor. Not exactly sure what's up. It's possible this was attached to something in the radio cabinet. Gee, I don't know. I don't know what that is. So that's the mystery. Let's find out what these things are. So I think I gotta get the schematic up on the screen. We can take a quick look at the schematic. Can raise an interesting question too at this point, which is when I played this radio, I don't think it hummed really at all. And how can that be in such an old radio with old capacitors, especially the power supply filter capacitor, that it doesn't hum? And my experience with these radios is as soon as you see a field coil, you're probably seeing a radio with very little or no hum in it. The filter capacitors play a less significant role. They're usually quite small, even 5 or 10 microfarads instead of your typical 50s you find in like a 5-tube radio. So a lot of the filtering is done in this coil here, I believe. That's why we didn't hear any hum. Another reason is there could be what's called a humbucking coil inside here, which is designed to literally counter any hum signal that makes it to the speaker. And that could be having an effect too. So it could be a hum in the radio, but it's kind of canceled at the speaker. So let's find out let's look at the schematic here and see what we can see. Okay, let's take a look at the schematic here. So this has been drawn in a very professional manner. It's a really nicely done schematic, and what makes this nice is the lining up. The lining up of these lines. See how they're equally spaced? In here, equally spaced. All these, all equally spaced. All through here, equal spacing. You know, from line to line to line. This makes a drawing like this much easier on the brain to sort out. You can look at it and see stuff much easier than if these dimensions were all different. Or these were all different. Some of these crowded in more and less and the like. This makes your brain work a lot harder to try to sort it out. So see, all the tubes are all lined up. There's another line up here. They've lined up all these switch wafers here. This is a well thought out. This is all lined up as is common the case here. Beautiful, beautifully done. Now, what's going on? So the first thing we want to look for is the gimmick, and the gimmick is attached to the 6SA7 tube. Let's zoom in here a little bit. Oops, oh, that's much better. We'll zoom in 6SA7. So it's the second tube. This is the first tube. See the antenna coming in here, going through this antenna transformer, feeding into here. The output coming out, going through this transformer, and then all piles of switches and stuff down here. Then making it into this complicated tube. Now, there it is, right there. there it is. C56. Let me zoom in just a wee bit more on it here. This raises a really interesting question. Two interesting questions about it. Approximately 2 picofarads, I'm sure is what that means. Capacitance coupler. And a little hard to see what it's doing here. It's between what is acting, this is a complicated tube, as I think that's a grid. And back to the first grid. Third grid. You got me as to exactly what this is doing, but it is exactly what I thought. So here's the interesting questions about it. Let's go back and we'll look at it in the radio here. So there it is there. It would have initially been longer, and then the technician during the final tune-up phase or alignment phase of manufacturing the radio, a technician would have been nipping it back and watching some instrument, and at the right moment he'd stop his nipping and go, that's perfect. And then this thing would be set to the correct capacitance. The question is, why was it untwisted? How did that happen? And the next question would be, how come this isn't soldered down here? Now, did that come right from the manufacturer without the wire being soldered? It looks solid now because it's hanging on to the other solid wire, but down here it's not soldered. And just in case you're wondering, what is this funny bump on the back of my finger here that I have? That looks terrible, isn't it? That's from guitar playing. I often play without a pick, and I drag my fingers over the strings, and this area hits the strings repeatedly, and I end up with this really whopping callus on it there. Actually, I don't dare play the guitar that way right now because it'll rip this callus off, and then I'll be sad. Okay, so that's what that is. And twisting it back into this position is probably good enough, certainly good enough for now. There's not much else I can do with it. I will resolder this though. Now the next mysterious wire might be a little harder to spot. That's this one. So we need to know where it's coming from. It's coming on this wafer switch. That's doesn't make it easy to figure out. Let me just turn the lighting up here in my shop. What's a humming? Well, maybe it goes to a spot on the wafer switch where there's a component. That's what I'd hope. I have to put on one of my super power devices here. Give me superhuman powers of observation. Where's everything? Down. It all looks so different. Where'd that wire go? Well, here it is, right here, sticking out at me. Goes to a terminal. There's another wire coming off it. Is there not a component? If there's a component, I can find it on the schematic, or at least it's more hopeful. The schematic may not show this in any kind of pictorial sense. So, like this capacitor sitting here on the schematic could be way off in another corner of the schematic. So, great big wax capacitor right in here, too. Okay. So, these wafer switches are numbered. Each position is numbered or identified somehow. For instance, there's 1, 2, 3, 4 wafers here. The back one looks single-sided. This one looks. It's got a terminal on the other side here. I'm not sure. Single-sided in terms of where the switch contacts are running. Some of these have a contact on one side, and then others have a contact on another. On the other side of the wafer, another set that helps identify them, but this one definitely has them on both sides. the switch doesn't help much. Wow, there's a very light wire right here. Oh, there's all kinds of very light wires. I got my magnifiers on, I can see them much better. The reason I'm going, oh, is it's really easy to break these inadvertently. Break them. Okay, let's go back to the schematic, see if we can figure out. See what we can figure out. What can we figure out? Okay, now the part of the radio we're in is this long. Let's see if this wonderfully drawn schematic can help. So here they've got a even more schematic picture of the switch. We have the knob showing you where the front is, so you don't get confused. Switch sections as located in chassis. Section S2 out on 981A, otherwise the same as shown. Section 32 out. Well, I guess what they're saying is this doesn't exist on a particular model. And I've got 1, 2, 3, 4. I got 4. They're positioned physically just like these, the way they're spread out. So this is definitely it. So the switch I'm interested in is switch number 3. Front and rear. So it's matching the radio. This is the front of the radio. This is the rear of the radio. Front and rear. So well, this connection is made. That's tricky to see, to the rear. It's made on the rear. Most connections are made on the rear. There's very few on the front. Now how's this? Where do we go from here? Well, here's the whole switch again. This time laid out so you can see all the connections. So they've sort of taken the switch and twisted these things flat. All these wafers flat. And there's more than 4 wafers here, so they've got a front and a back happening. They must be labeled. Let's go a little closer. Yeah, front, rear. This is probably the front, rear. Well, where's the actual switch number? S4, S3 on 981A, S4 on 981X. So we've got some variations here between models of this radio. And the one I've got, I think it just says 981. Isn't that all it says? Mine says 981. Oh, I think there's an X there. Just one second. Let me just look with my own eyeballs here. Yes, 981 with an X stamped into the plate. So I got a 981X. So S4 on 981X. That's what this is. But we want S3. S3, oh, see, because there's one switch less on one of the models, the numbering is different. That's why the confusion comes in. But S3 on the 981X. So this is the switch. You can hear my dishwasher in the background. So now we want to figure out, well, here's a couple things. Here's a couple shielded cable coming up. That's easy to identify. Here's the numbers. The numbers. So we can guess that if you look at this wafer from the rear, you would see the numbers this way. And if you look at the same wafer from the front, but you look at this front side of the wafer, you would see the numbers this way. Okay, that's great. That's great. Okay, that's really great. Now, they're showing pictorially here too. Almost certainly, this funny shape here is not a circle, right? It's a weird shape. Exists, so I'm looking to see. Okay, I can see the shape. And now, would this be the top? If this is the top, then it's got these 2 wires connected on the top part. There they are. I see them. Okay, pretty sure I know what I'm looking at now. So this is the wafer of interest, and I think it's going to be one of these 2 wires. One of those 2 wires. Okay, so one wire, I can see one. I can see one going to the chassis. That must be this one. So that would be 1, 2, 3 down from the peak of the switch. So is it 3 down? It's Well, it depends how you count these terminals. Depends how you count them. I didn't, so I counted these circles here. I should just count the soldered to connections. So it's the second connection down from the top on the front, which is actually on the inside front, going down. 1, 2, that's it. It's a ground. So I see this connection. The very next wire is the wire. The very next wire, I'm looking here. Well, not quite. Not quite. This doesn't look like this. Oh, here we go. Okay, so I've done something wrong. Now I'm gonna, you know what I'm gonna do? I'm gonna stop. I'm gonna put a camera image of the switch up on the screen here with us, so we can look at it at the same time we're studying this diagram here. Okay, here we are. So this is the wire. We're trying to figure out where's that supposed to go. There's a terminal that's going to ground. Here's the peak of the switch, if you like, the wafers. This is the top as shown on the diagram, although it's sideways in the radio, the way I have the radio set. Perhaps that this is actually the bottom here, perhaps. I don't know. But the wire in question is going way down into the back here. Way down in there. You can see it there. So we want to trace on from there. Okay, let's try this view. Okay, we'll zoom in on this. And where are we looking here? So we're looking at the third wafer switch. Back, front side, down from the top. Here, switch 3, here we are, front side, down from the top, skip one terminal. This is actually on the other side of the wafer. This one has the wire. Oh, this is the other way around. This is the connection, and then the next connection is going to ground. Oh, okay, so here's the connection going to ground. Oh, that's just fine. Here's the first one off the peak, then the second one, then the third one is the one that goes to ground. This one's on the rear, this is on the front, this is on the front. How's that add up when we look at the diagram here? Front, so we find one going out the back. The next attachment is a capacitor. This isn't adding up at all, is it? And then the next attachment is a wire going to ground. But this is just not matching. Not matching. Okay, well, we have a capacitor right here. It's right near the connection, like it's just a few terminals away. Where's this capacitor showing up? Now, although the capacitor in the radio is tied directly to the switch, it's not necessarily shown that way. So go back to the switch of interest. Who's got a capacitor on it? That's a variable capacitor. That's the wrong kind of capacitor. There's one here, but it's on the other side of this. Can't be it. Can't be it. Besides, there's a ground right here. So no, then no, nothing going that way. Here's a capacitor. 0.01. And then the other side goes to a transformer. Okay, looking at the radio now. Other side goes to a transformer or a coil right here. Okay, so I think I know that this capacitor. I think I know that capacitor. So that capacitor is hooked up here on the second pin. second pin. So here's the first pin on the wrong side, and we have the second pin. There it is. And the third pin goes to ground. That's what the diagram shows. And then there's nothing more connected. But there is. This piece of wire is connected. This piece of wire. Okay, so it's connected to a terminal. Is it connected? Is there anything else connected there? It's so easy to get fooled. This green wire right here. So what you can see back here, it comes. What's it doing? It's doing a funny. Behind this capacitor, it turns sharply and comes around to this terminal right here. You can see a little bit of it. Just be sure here. This is how you get fooled. There it is. Now there's no question. Okay. To move any of these components into a different position physically, you could cause problems with the operation of the radio. So it's hard to say for sure. But in this is the RF end, and carrying the antenna signal basically through here, and the amplified version of it. And those high frequencies can be they're very sensitive to the location of all these parts. So as much as they look kind of thrown in here, they aren't. Okay, so what do we know now? So now we know this wire attaches to a terminal on the switch, and a green wire that comes up to the same transformer as this capacitor. Okay, there's a hint. Let's follow that out. So we say there is a wire. You know what may be going on here is the terminal on the switch actually doesn't go anywhere. It's just being used to connect two wires together. It's possible that that's what's going on, just to add confusion. Because there's nothing here. So we'll follow that capacitor. It's going to identify the coil. Here's the coil. Now the wire is coming RF, broadcast RF coil, that's what that's called. And this little thing here is saying this is I think this is saying it's an iron core coil. That's a little odd. Not exactly sure what this is. If it were a variable adjustable coil, it would have this arrow drawn through it. There's no way these are iron core coils, so I don't really know for sure what this is. There isn't such a thing on this. I don't know what that is. One side grounded. Other side has a wire. Don't lose track now. There's a wire coming to the rear. It's a bit of a mystery, isn't it? How would this get to be this way? And where's the rest of it? I mean, if you cut a wire in the middle, the other part of the wire's hanging here too. Or have I just not found it? No, I can't imagine that. I would have seen it by now, I think. And the radio seemed to operate with this wire hanging here. Okay, let's just try again. So we know the wire comes to here, and we see capacitor coming to a different terminal. And we see this pinkish wire heading off quite a distance, way over to a IF transformer. So we have an IF transformer connection, we have a capacitor connection, and we have the mystery wire connection. We find those three on here. We can't find three. We can only can find two, Jim. You're not going to find this third one. Okay, we'll work back from the coil. The one lead goes to ground, so that's not the one. So another lead comes off, goes to a capacitor. Okay, so do we see another lead coming off here, going to a capacitor? It's not this red one. One going down to the switch. Another lead, another wire is this one here. It's just going to a terminal here, no capacitor. Well, this is not adding up very well, is it? Not adding up. Now my options here are just, ignore this for as long as I can. Maybe all the way to the very end. Return the radio with this wire still sitting here. I think I would put some insulation on it though. Another way is to try to look for some kind of deficiency in the operation of the radio and then blame this wire on it, and then somehow that's going to help. Not sure how. This is quite mysterious. It'd be if it were a factory test point, they wouldn't do this. They wouldn't have a wire sticking out for a test point like this. It just wouldn't happen. So the owner of this radio has said that this was her father's or her grandfather's radio initially, and that he did do some stuff to it. And I think one of the things we know he did is that wild power cord that was put on it. And he probably spotted, this guy and wondered what this is. And then he probably untwisted it to get a better examination of it. How it got unsoldered down here, I don't know. But I know I'm going to solder that up right now because I don't know what else really to do at the moment. Okay, let's do something useful. So I now know what the gimmick's up to, or at least actually I don't know what it's up to, but I know it's valid. It should be there. And the one wire's not soldered. It's very, very curious. I didn't think it came out of the factory this way. Well, it's possible. I mean, anything's possible. Let's see if that did it. Because it's twisted around the other one, it's just a little tough to spot. Maybe that's how it would come out of the factory. Nobody could tell. It was, yeah, it's definitely soldered now. Okay, very good. Of course, you think after a long time, a component drifting, especially maybe coils changing somehow, I don't know how, but somehow, so maybe this is no longer a valid value in the radio. It needs to be corrected. Now, I'm not going to worry about that right now, but how would you correct that? You have to twist some new wires on it and repeat the cutback process, I guess. Never done that. But I have untwisted these. The first time I encountered this in a radio, I did not know what it was. And I did exactly what was done in this radio. I untwisted them and looked at them, left them untwisted. I thought, wow, something was there, and somebody cut it away. No, not the case. Well, there's really nothing stopping me from doing the capacitor work. Oh, you know what's stopping me? I don't know about the performance level of the radio, and I don't know about this yet. Let's consider this one. Let's look at this. What has been done here? Why would somebody do this? I want to bypass this capacitor. So this capacitor, is it playing an important part in the radio in terms of its tuning, or is it just some kind of like protective sort of thing? It could be part of a filter right on the antenna, and bypassing it may not be the best idea. Let's go look at the schematic, and we'll look at the front end, how the antenna is connected, and all that kind of stuff in this radio. Here we go. Okay, like a lot of radios, the antenna is actually not directly connected into the radio. It's actually, I'm going to take that back a little bit. There's a connection here that appears to be going directly into yow, who knows. But the signal is making its way into the radio, especially reaching this first tube here through this transformer. These transformers can be subjected to high voltage by accident, lightning effects. I don't say hit by lightning, but nearby lightning, long antenna. These coils are sometimes burned out. And I'm not saying that's the case here, not at all. There's the capacitor. They wrote 10% on it. That's a hint. These capacitors are generally plus and minus 20%. And so here's one that's actually got 20% written on it. Wait a minute, what's this one say? 10%. Makes sense to write. Look at this one. I think this one says 5%. What are they doing here? Let us zoom in. Zoom in? Zoom in, please. Unfortunately, it's not the best. Copy here. 5%. 5%. 5%. They're writing it on almost every capacitor? Not really. 10%. 20%. So you're like, why would he even write that? That's sort of the industry out of the end of the factory where they make capacitors. That's their sort of standard go-to. So you only pay more money to get something better than this, to get a 10% or even 5%. Let's go back and look at it. So I think we can assume there is something a little bit special about this capacitor. 22 picofarads, 10%. It could be forming some kind of tuned circuit through here. Who knows what? I sure don't. Here's the switch, which is sometimes connecting a ground and sometimes not. Sometimes connecting a ground. Well, if you put a ground right here, this coil is nullified. This, I'm going to guess, this is the AM coil. I'm going to guess. What's this symbol? What's going on here? Now this looks like a chassis symbol with a couple of teeth missing. But we know these grounds are made to the chassis. What are they suggesting with this? This is an outside earthing connection? As in a rod shoved in the ground? Okay, that's another mystery as to just what exactly this toothless fork is here. Maybe we can even find this and see what it is. That's an interesting idea. What have they done? My last radio I was complaining about German engineers and their tone control madness. Madness, I tell you. But anytime you come up with these switches in a multiband radio, it's madness also. Madness. Just craziness. In this schematic, the person who drew the schematic, and this is quite common, has drawn the signal path in a heavier line, if you can spot it. Like, see this line here is heavier? See it's heavier here? This is showing you the signal path. Now, it didn't do any heaviness out here. But once you pass this tube, the signal is shown in a heavy line, so you can trace it right through the radio. What are we doing way over here? Wait a minute. What is this heavy line showing? Well, okay, I can understand it coming, like it should be heavy onto the grid. We can't see inside here what's what. Oh, a little breakdown in the drafting happened right in here. with this line. This line, I think he drew this line in very late in the game. It's kind of breaking all the rules here. Does that say two band? I have trouble reading that. So in the early stages of repairing a radio, it's good to rummage around the schematic and rummage around the radio too, and just kind of gawk around and look at curiosities like I'm doing. I lost track of where I was. And losing track of where you are. It's all helpful, because that's how you discover stuff. Yeah, I lost track when I zoomed out. Now I'm losing track of what I was even talking about. Was this line here? C band? Looks like hard, H-A-R-D, but it's not that. It's got to be band, B-A-N-D. 31 meter and shortwave C-band. Is there a C-band in this radio? A band called the C-band? Maybe it's the B-C band as in broadcast? The B, it's a B? It's a poorly drawn B there? I don't know. The guy's line work was okay, but his writing is terrible. The draftsman who did this is just terrible. This is unpracticed writing. Like, this is terrible. It's not high quality draftsmanship here. But that's where the junior engineers start, right? In the radio factory, they start by being forced to draw these diagrams. Yeah, gets them into conversation with the senior engineers who are building the prototypes and designing the radio. They get to a lot of conversation. It's a very, very good way to bring up a young engineer. Well, no idea what that wire is yet. No idea really where it's going. No idea what the impact on the radio is, having that wire sitting there going nowhere. The other wire, I'm talking about, whoops, I got my wires mixed up. I was talking about the one I've been looking at in the section 3 switch. Now back to the antenna, mystery antenna wire. The mystery antenna wire, the black wire, it's black too, which almost suggests a ground. It come in and can attach right here to what's that? Strip antenna? Oh look, okay, here we are. This is the wire right here. This is the wire. I thought this was a ground thing when I first glanced at it, but it's not. It's just an arrow to something antenna. Almost certainly this is a wire running around the inside of the cabinet, and the connection to it is made from the from that wire, from this wire, as a connector, like a what do you call it? A connector right on the end here, screw connector. Okay, that's what that is. So when using the inside cabinet antenna, the connection is made bypassing this resistor. But if you're going to use an external antenna, I said resistor, capacitor. A capacitor is used here. A critically sized capacitor. Well, it could just be some basic impedance matching of the antenna against these coils or this transformer. Something like that could be going on. So when I'm talking through my hat here, so don't believe what I'm going to say. But maybe the antenna is considered too inductive for this radio, so they throw a little capacitor in series with it. But don't quote me on that one at all. Okay, so that answers that mystery. So now we're down to just one mystery in the radio. Oh, another mystery is I didn't realize I'd left this camera going all this time. Oh, for crying out loud. So I apologize for that, not paying attention to what's actually going on. Let's stop for a sec here. So the thing about working on a radio like this, and I'm lucky in this case because it's largely operating, is as you're working along on it, things happen, You want to attribute those things to what you've done, whether good or bad. So you kind of have a notion of what's happening in the radio as you work away on it. With these mysteries sticking out, can't be sure the performance of the radio is legitimate. And as I replace parts, that what happens is also legitimate. Probably is inconsequential. But let's just go forward here a little bit. Let's see if I can put this great big thing on here. I think it's too big. It's not going to stay. I don't want that wire hanging out there. Do I not have a smaller one of these? It's the same size. Let me get a smaller one here. Okay, very good. Now, got this covered with some tape. Got this covered. We know what this is. That's put back together and soldered. Let's give this radio a performance check. Try to receive on each band and find out how well it works on each band. Ooh, did you see that? Did that go flying by? That was a camera. Falling to the ground. Oh my gosh. That's too bad. Okay, still working on it. Is this string going to be in a stupid place, like laying up against a hot tube? No, don't think so. Just laying there doing nothing. That's fine. So I just want to check the power cord. Make sure it's good. Got to set the antenna here. Okay, plug it in. Get it warmed up, and I'll go deal with the antenna while it's warming up. That's the volume. Volume down, volume, band, tuning of nothing. Volume's down. Hey, what's this? What's this? Then what's this? One of these has got to be tone. There's too many knobs here. And I do not have the cabinet to look at. There's just too many knobs. It's unnecessary knobs here. Let's get it going. You can see the dim bulbs here too. Always a little nervous at this point. Fire on. Okay, you can see the light came on right here. Very low voltage to start. 87 volts at the moment. Now it should go down. There. Oh. Here it starts going. There it goes down. The tubes are trying to conduct. They're having a hard time at 87 volts. So I am a little nervous about operating this still because it's only been in my shop for a short while. So I'm going to turn this up using the variable adjustment here. We'll force this up and get it over 100. So I have these lights in the circuit dropping the voltage. So okay, so we're in the mid 90s. Probably good enough for what I'm going to do. First observation here is the magic eye is completely dark back here. I cannot see the filament either. There should be a bit of a red glow in there you can get at. If you just look on a right angle, I don't see anything. That's not a good sign. What's this? Volume or tone? This is volume, isn't it? Maybe not. Maybe this is volume. Is anybody volume? Well, we have no antenna. That's why we got no volume. Right, I'm going to let this guy warm up. It's going to go deal with the antenna. Right. Back on plan here. Okay, so this lead leads to an outdoor antenna of It's okay antenna for, you know, a house in a town with limited property. We're going to hook this antenna up. And this radio has no like built-in AM antenna. No noise there. Which is which? So this is the antenna. Don't know where that noise was coming from. How about this? It's not a good sign. So I expect to hear quite an announcement from the speaker. That's better. As I found in the past, sometimes these particular kind of connectors are very I guess they build up a non-conductive patina or something. They become very difficult to get a good connection. Ground should go quiet because it's a very low impedance antenna ultimately. We'll leave it off right now. These things are usually built for a long wire antenna and a earth ground, not a dipole antenna type thing. Lots of interesting sounds coming out of there. Exactly from where, I don't know. Not a loose tube. Okay, I'll swing this around. So we can't really do a really good performance test with an antenna, but we can certainly have a look at what's going on. This wire's a bit of a problem now. Sticking out there. Looking for a chance to ground to that speaker. That would ground the antenna. That wouldn't help. Not the best tape job there. That'll do it. Now, what about this radio? So it says we're on the broadcast band according to the light here. Let me just douse the overhead light. Broadcast band, and we will tune. I can tune it by hand right here. The pointer's not going to go anywhere. Okay, so let me. So that sounds like a short in the tuning capacitor. Oh, how come it didn't come back? Well, that's not good. Where did it all go? I had a few crackles and then it all went away. This shouldn't have caused that to happen. Just turning just turning the capacitor wheel here. Huh. How are we doing for voltage? The lights aren't flickering. The dim bulb lights are remaining. So I've still got this running on low. So I gotta watch those dim bulbs very carefully. Can you see they're jumping with that sound? Even this light is jumping with that crackling sound. That's a very bad sign. Something that draws power is shorting out a little bit inside the radio. It could well be that it's shorted out and it's actually the opposite. It's releasing. It's trying to go normal. Especially since the radio went kind of dead. Did it go dead? It's still there. It's just very weak. How come it went so weak? Antenna's still connected. That sound is typical for AM radios in my shop here. Now, what is the volume? This must be volume. Nothing else is going to get there. So I'm sure this can't go over the video, but the impression I get when I turn this up is the set is oscillating at a frequency just above where I can hear it. Kind of weird. How can you know it's oscillating? I just have that feeling in my head. This is tone. Maybe this is treble and bass. Yeah. This now, the switch can be dirty and all kinds of trouble with it. Let's check that out. Set this volume about a third. Wiggle this. No, doesn't sound so bad. Did I just see the lights flash? It's this light flashing. Watch the dim bulb here when I switch to this other band. I don't think it should be. Can you see that in the camera? Yeah, you can see it. What's going on there? That's not normal. Okay, so we're top band. And this is just to add more confusion. They put the broadcast band in the middle because probably the marketing people said, no, put this right in the middle. Okay, so that's the first band is the middle. The second band is the bottom. Really? Third band, they're working your way up. So you don't come from the top down? They don't start at the top and go down? They start in the middle and go to the bottom and up. No wonder I got all turned around on this. Or is this one all mixed up too? Like the other similar radio I did. Okay, let's do what we are intending on doing here. Even with virtually, I got full volume here. It's not good at all. Oh yeah, there's no pointer to watch. So watching the plates. Plates are completely unmeshed on the capacitor. The plates of that thing there. Right here there's a station. Doesn't sound like much. Let's fiddle with that ground connection on the antenna now. If I make the connection, right there. Got no more volume to play with. Didn't seem to bring in a station though. Now we gotta be quiet to even hear it. Yeah, so that's not helping. Take the ground back off. Now what if we feed that signal by, we'll use the wire I so carefully taped up. What if we bypass? I just remove my tape job here. Is it any different? Can't imagine. Okay, tuned in that shrill noise. If anything, I think it's better on the terminal going through that capacitor, but marginally. Okay, one band, we got nothing. We got nothing here. What's all that? What's going on? Who's crunching? Oh, wow! She's ready to come back to life. Could be a loose tube. That's the usual culprit in these cases. shaking the tube. I'm shaking the whole radio. These aren't too hot yet. These ones back here, these could be hot. Oh. Did I hit it? Was that the guy? Another thing about this kind of stuff is, you know, stuff happens while you're doing something, you want to blame it on what you're doing, but maybe not. It's just a coincidence. Anyway, we got some volume back. Somehow. We don't know how. But we did. Now we'll check that station out. Still not happy. Good enough. We'll go to the next band. This is a general shortwave band. Goes all the way from 6 to 18. Make it very covers the whole shortwave band. Volume up, full blast. Don't hear a thing. I'm listening very carefully. Excuse me. Pretty silent. Not a thing. Next band. 9 megahertz band. Dirty switch here. Okay, not so sure about this. That's full volume too. Broadcast. Very quiet. Go tuning. Now there's a strong station located at 9 point, well, it'll be right down here, I think. 5? Oh my gosh, that's 5, that's 4. No, it's way off, way down here. It's off the band. Let's go see what we can find here. Somebody, anybody. Just a lot of noise. Not a thing. Not a thing. Okay, next band. The light's gone out, but we know we're working our way up. We've gone to this band where the light bulb's missing. 11, we should hear stuff. There should be stuff here. Okay, tuning through the band here. They all seem the same, don't they? So all the shortwave seem the same. Meanwhile, the AM seems to work. One more band. 2 more bands. What happened? I got confused on the switch here. No, the last band is for operating for a phono input. Pretty sure. Back one. So we're up here now in the 19 meter band. Should find stuff. Okay. Starting at one end of the band, coming back. See, it's got all these neat little words on it. Budapest, Berlin, San Francisco, London, Rome, New York, Hilversum, Oslo, the Vatican. Put down here. Panama, Winnipeg, Stockholm, Boston, Prague, Pittsburgh, Melbourne, Chungking. Really, it says Chungking there. I didn't know that was a real place. Well, as you can see, we're picking up absolutely nothing on this band also. So that kind of tells a story, but not quite. We have to do one more test here. I have to do something more yet. Okay, so I have the radio on the broadcast band here again. It's doing pretty good. I'm looking for a dead spot or a quiet spot. easy to be fooled here. The quiet spot could be because there's a signal, like a noise signal, interference type signal with no modulation. Just make the radio go quiet. So hopefully that's not the case. I'm tuned somewhere in the middle here. Don't know where because no spring, no pointer. I've got my signal generator operating here. And what we're going to do is we're going to force in a signal using the signal generator, and then we can control how strong the signal is. And then we can make some deductions about how sensitive the radio is. So obviously, broadcast band, very sensitive. Turn this down. We got to find out where we are. So I'm up at 12 megahertz here. That's a little high. So here we are. I'm just going to tune this downwards. I'm feeding it's connected to the antenna. I'm feeding a moderate signal. Should pick this up. Okay, so we maybe tune less than 9. I'm going to tune the radio and see if there it is. That tone you hear. It's my signal generator. Prove it. Let's just go up there right on the end. Let's put it to 1 million. Let's do that. 1 million. Find it again. There it is. Now we just move the pointer by hand to 1 million. There we are. She's fixed. Beautiful. I'm going to weaken the signal and see when we can't hear it anymore. Barely hear it now. Barely hear it. I'm going to do a little calibration number on this thing just to find out where we are with it. We're way high, way high, way high. Okay, calibrate it back. So that is now that's a 1,000 microvolt signal. You can't really be sure what exactly is on the antenna here for reasons I won't go into, but something around that 1,000 microvolts. It's not particularly sensitive. Sound sensitive, but okay. It is a broadcast band. We'll go to the next band. This is really what we want to do. We're right around 10 megahertz. I'm going to fire in a signal around 10 megahertz, and then we're going to pump it up. Here we are. Okay. The problem with doing this is we don't know exactly where we are, but you see I moved the pointer over and left the tuning alone, so we're somewhere around 10 or 11. I don't hear a thing. Now we're going to start beating it up here. So this next signal level, I just increased it by a factor of 10. This is now what would be similar to a very, very strong signal coming in on an antenna. Can we hear it? Can we find it? I'm going to tune the radio. It's easier. Radio's range is, so we think we're right around 11. Right around 11. Okay, good. Let's tune the radio and see if we can find it here. Nothing whatsoever. So now I'm going to pound it. This is a stupidly strong signal now compared to any antenna. This is really sending out a strong thing. There it is. Seems a little jumpy. That's full volume, barely coming through. So it's working, but barely. Okay, let's do another band. Down. So this band is actually a little piece of this stretched out, spread out, spread band. This is a spread band from this part of this general coverage band, if you like. So we're a little high. I'll set that to like 9.55. 955. You got the pounder signal coming in. Where are you? As I'm doing this, I'm noticing this light is flickering, and these lights are flickering. they shouldn't be flickering. And you have that scratchy sound of something failing. There's just no performance here. Am I doing everything right? That's 9.5. Well, unless these lights are mixed up, we'll assume they aren't. So nothing at all. We'll go up to 11 now. That's 11. No light. Volume full. This is 11.8, right in the middle. We'll go there. 11.8. Full smashing strength signal being supplied. Of course, where this pointer is doesn't mean anything. It's up to this. Well, I think nothing. I think nothing is all you can say about that. Go up one more. We're up here now. 15. Let's say 15.2 right here. We'll go 15.2. Let me check the calibration. We're low over here. We were low. We were low on that last check. I have to go do the other band. We can hear it here though. Just nothing. She's dead, Jim. Okay, I think that's the end of it for today. The on-off switch is down here. This is on-off. Oh, it's a pointer. It's a needle slamming into the top of its range. Okay, we're done for today. None of this is too disturbing to me. This is just gives me an idea of where the starting point is. As long as one of these bands is working and the broadcast band is working, then we're in pretty good shape here for restoring this radio without too much anxiety and fear. Okay, that's great. Thanks a lot for watching, and tomorrow we'll start looking deeper into these performance issues and begin replacing capacitors that we think might be responsible for the bad performance that we're getting in the radio. We may explore it a little further with some test equipment. Maybe the signal is getting through the radio all the way near to the speaker, and then it can't go any further. That's not likely. I won't get into the details of that, but that's the kind of thing we can kind of think about tomorrow. Maybe try to hunt down a bad actor that might be in there. Who knows? Thanks a lot for watching, and have a great day.